Okay, dear student, let's see what is there in this question. What is the unit of resistivity in the fundamental SI units? Okay, so this is quite tricky. So I told you that whenever you are going to for the topic D1, D2, D3, D4 and the topic B5, be very careful about the units, because you might be getting this kind of a question and it will be very hard for you to find the unit for something which is electric in nature in the fundamental units. So that's quite tricky, but let's see. Let me show you how tricky it is. Now you want to find the resistivity in the fundamental units. So first of all, what are the fundamental units, because that topic is not in your syllabus. So there are 7 fundamental units. So let me give you the list of all those 7. So starting is kgs, and then meter the length, then second time, and for the temperature is Kelvin. For the light it is candela. For amount of substance it is mole. The quantity is known as amount of substance, it is mole, candela, Kelvin. And the 7th one is amperes for the current. Yeah. So these are the 7 fundamental units. So we have to convert the unit of resistivity into these fundamental units. Now what is the unit of resistivity? You must be remembering it is ohm meter, or you can even derive that from resistivity from this formula. Resistance is equal to resistivity into L by A. Now this ohm has to be broken down couple of times. Let's see. So ohm is resistance. How many formulas do we know? Like only one formula, V is equal to IR. So it means that ohm is equal to V divided by I. What is the unit? Volt divided by the ampere. Okay, no problem, let us have it. So ampere is the fundamental unit, so no problem, but volt is not in this list, so I have to think about the volt again. Now what is volt? Volt is kind of like potential. The unit is volt. This is written as the potential energy divided by charge, isn't it? This is coming straight away from the topic D2 HL. So PE divided by Q. Now potential energy, the unit is joule, and for charge it is coulomb. Now both of them are not in our list of fundamental units, so we have to break both of them down. Now what about the joule? We have to think of another formula. Now we can say work is equal to F into S. Yes, the work is having a unit joule. Force will be Newton, displacement will be meter. So joule is equal to Newton meter, but Newton is again the composite unit. So let me break down that here. Now F is equal to M into A is another formula that I'm using. Newton is equal to mass into acceleration. Kg meter per second square, multiply by meter, it becomes meter square. So joule can be expressed in fundamental units in this manner. So that will be substituted here. So it will be kg meter square divided by second square divided by coulomb. Now coulomb is again not in our list here, so what can we do? But I know that I is equal to delta Q by delta T. From there we will find the coulomb. So from here I can say that the delta Q is current into time. It can be written as ampere second. So this will be ampere second. Now this is potential, so I would be substituting in the potential. So the resistance ohm, oh my god, so for ohm it will be second cube. I am making this second and second, and there is another ampere here, it becomes ampere square. So this is ohm. Now this ohm is later multiplied by meter, so this is again multiplied by meter. So for the resistivity it is kg meter cube second minus 3 ampere minus 2. So it is kg meter cube second minus 3 ampere minus 2. Oh my god, this is how we do it. So you keep on opening the brackets and brackets and brackets. So first of all it was ohm. Ohm has to be broken down into volt per ampere. Then volt will be broken down into joule per charge. Then it will be broken down into Newton. Newton will be broken down into the fundamental SI units. So this is how we do it. If there is any problem, please do mention that in the comment section. Okay, dear students, all the best. So C is the correct answer for this question.